Okay, you need to be on this page in your comp book. Pause until you get there. Let's go. We're multiplying positive and negative fractions. You've done this before, but this is a good review, especially now that we have positive and negative numbers, right? So when we have negative 15 times 2/3, we can't multiply it like that. So we're going to have to put the negative 15 over 1, right? Because that's what we're talking about. We're talking about negative 15 wholes or negative 15 oneths. We multiply that by 2/3. Notice also that I put my negative with my numerator. That's just the way we think about it. Whenever we have a choice, when the whole number is a negative, we're going to think about the numerator as being the negative when we have an improper fraction. Okay, and now what I can do is I'm going to do it the normal way, the safe way. So now my numerator, I just multiply across the top. Multiplying fractions is so easy. Okay, negative 15 times 2 gives me negative 30. 1 times 3 gives me 3. So now I have negative 3/30ths. Or, negative 30/3. Okay, but not only is that a mixed number, or an improper fraction, but it's also not reduced. Well, and so I could just do simple division here. That's what this means, right? This is division. If I have negative 30 pies cut into 30 pieces of pie of thirds, then I put them all together, I have negative 10 pies, I guess, that I have to bake tonight. Okay, another way to work this out. So think about it. I want you to think about this. When I had this negative 30/3, what did I reduce by? I first got to negative 10 oneths because I reduced by 3/3, and then I just divided. So keep that in mind here, because what I'm going to do it a slightly different way that some of you already know. Negative 15 oneths times 2/3. I'm going to look across my numerator and my denominator here, and I'm going to look across my numerator and my denominator here. And if I see any way that I could reduce, like let's pretend that this was a fraction and let's pretend that this was a fraction. Could I reduce? Well, yeah, I could reduce this by 3/3, right? So again, don't pay attention to this. If this is hard enough for you that you want to stay here, that's fine. Okay, but when I look at negative 15 and 3, I see that 3 goes into both of those. So I'm going to reduce right now that pretend fraction. Negative 15 divided by 3 gives me negative 5. 3 divided by 3 gives me 1. And that's what I reduced this by, right? I reduced by 3/3. Here I'm reducing by 3/3. Well, now when I multiply across the top, I've got negative 10 oneths. And it's really easy to simplify that to negative 10. So this is a shortcut that you can use once you understand the pattern, what you're really doing. Go ahead and use this. If you don't understand this, don't use it yet. But keep on the lookout for this. All right, B, go ahead and do B. You got it done? Okay. So once again, I have to put the 2 over 1. So I have 2 oneths times negative 1/6. Notice how I moved my negative sign up to the numerator. I could cross cancel by 2, but let's go ahead and do it the normal way. I'll get 2 times negative 1, so I multiply across my numerator, I get negative 2. Multiply across my denominator, I get 6. I have negative 2/6, I can reduce. Divide the top and the numerator and the denominator both by 2, I get negative 1/3. And again, I could do that by cross-canceling. 2 oneths times negative 1/6. 2 goes into both 2 and 6, so I'm going to reduce both by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. Multiply across my numerators, I get negative 1. Multiply across my denominators, I get 3. Negative 1/3. So I kind of saved time because I moved this step into right here when I worked with my original problem. All right. Multiplying fractions to fractions. Go ahead and do that one. Oops. Ooh, you didn't see that. Go ahead and do that one with your neighbors. You done? Okay. So I have 1/4 times 4/5, and I can cross cancel. So, but the number 4 goes into both 4 and 4. Imagine that. So if I divide 4 by 4, I get 1. If I divide 4 by 4, I get 1. Now I can multiply across my numerators. I get 1. And multiply across my denominators. I get 5. And I get 1/5. Any other way that you did it, you should have gotten to 1/5. You just had more steps. Not a big deal. Here's the longer way. If I had multiplied across my numerators, I would have gotten 4, multiply across my denominators, 20, and reduce it to 1/5. Voila. All right, go ahead and do the next two on your own. There's really no room to do this one. Go ahead and do it on the back of your foldable. Well, I guess you're folding this way. On the back of your foldable. Done? Already? That was fast. All right. So 3/4 times -1/2. I can't cross cancel, can I? There's nothing that's going to go both into 3 and 2. These are relatively prime. There's nothing that's going to go into 4 and -1. Those are relatively prime. So I multiply across my numerators. I multiply across my denominators. I get -3/8. I can't reduce it. I'm done. All right. I'll tell you, this last one is a lot easier if you were able to cross cancel. I've got -8/9 times 3/11 times 33/40. Yuck. Well, I'm going to take my first two terms, and I'm going to cross cancel. What goes both into -8 and 11? Nothing. But what goes into both 9 and 3? 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Now I can multiply my numerators. -8 times 1 is -8. 3 times 11 is 33. Bring down the rest of my expression, times 33/40. I can cross cancel again, both this way and this way. 33 goes into 33 one time. 33 goes into 33 one time. I can also divide both of these by 8. -8 divided by 8 gives me -1. 40 divided by 8 gives me 5. Multiply across my numerators gives me -1. Multiply across my denominators gives me 5. My answer is -1/5. Yes, I could have done that the longer way, but oh my goodness. -8 times 3 is -24 over 99 times 33 over 40. And then I multiply. I mean, this is just, it's ugly, right? Oh, I did reduce here a little bit to try to save some time. But, I mean, -264 over 1,320. Try to see what's going on with cross-canceling. It will save you a lot of time in the end, because if I reduce and I reduce and I reduce, eventually I will get to -1/5. But again, if you don't see how cross-canceling works, if you don't see what's going on here, stick with this way, because this way will not fail you. All right, multiplying mixed numbers. I cannot just do 8 times 2/3. Cannot. I cannot do 8 times 2 plus 8 times 2/3. Can't do that. What I have to do is I have to multiply this number by this number. So I have to turn it into an improper fraction. 8 times 2 and 2/3. Well, I already know I have to put 8 over 1, so I get 8/1 times, well, I go around the world. 3 times 2 is 6, plus 2 is 8. Wow, how did I do that? Let me fix that real fast. That's going to be 8/3. Ooh, this will be fun. Okay, so 8/1 times 8/3. I can't cross cancel. Multiply across my numerator. I will have 64. Multiply across my denominator. I will have 3. And now, somewhere on scratch paper, I'm going to need to simplify this. 64 divided by 3. Well, 3 goes into 6 twice. 2 times 3 is 6. I subtract that, I get 4. 3 goes into 4 once. 1 times 3 is 3. Subtract, I get a remainder of 1. So this is equal to 21. My remainder becomes my numerator. And my original denominator, my divisor, becomes still my denominator. So that equals 21 1/3. Ignore what I'm about to do because that was all wrong. Okay. Actually, I'll stay there. Yikes! There. Okay, go ahead and do the next two in your groups. Ready? All right, let's go over it. Okay, so 1/3 times -4 1/2. Well, I can keep 1/3, but I have to change -4 1/2. It's going to become -9/2. Is that what you got? Oh, good, I did it right this time. Okay. Let's see. I can cross cancel. -9 divided by 3 gives me -3, and 3 divided by 3 gives me 1. So multiply across my numerators. 1 times -3 is -3. 1 times 2 is 2. I have an improper fraction. I can do this in my head. How many 2s, how many halves can I get out of 3 of them? Well, I can get 1 whole and 1/2. And C. 3 3/5 times 1 1/12. Change them both into improper fractions. I get 18/5 times 13/12. Can I cross cancel? I sure can. By 6. 6 goes into 18 3 times, and it goes into 12 2 times. It's going to save me a little bit of time. Multiply my numerators, multiply my denominators. 3 times 13 is 39. 5 times 2 is 10. Now I figure out how many groups of 10 can I take out of 39? 3, and I end up with 9 left over. 3 and 9/10. All right, we have a word problem. First thing to fix is down here. There was a typo. The Bay Bridge toll for a car was how much in 1939? So here's our word problem. In 2005, the Bay Bridge toll for a car was $3. In 1939, the toll was 2/15 of the toll of 2005. What was the toll in 1939? Before you get started to working on this in your group, I want to give you a hint. I want to give you a similar problem. Imagine I'm going to buy cookies. They cost me $6. Oh my goodness, these are such good cookies. $6 is worth it. Okay, so $6. But they're on sale for half price. So I'm going to pay a half of that $6. Well, you already know in your head, what is that? That's going to be 3. I'm going to get that for $3, right? Well, how could we write that mathematically? We could say 6 divided by 2 is 3, right? Because that's really what this fraction means. Or I could say 6 times 1/2 equals 3. So keep this in mind as you are working on this problem as a group. Did you get it? Are you sure? All right. How did we have to write that out? Well, we have $3 that they originally are, and we're multiplying it by 2/15 to figure out what 2/15 of 3 is. Just like we figured out with the cookies, how much is half of 6? Well, we can't multiply a whole number. We've got to change it into an improper fraction. So we have 3/1 times 2/15. We can cross cancel if we like, or we could just say, oh, that 2 times 3 is 6, 1 times 15 is 15, and then reduce. See how both ways always works? Okay, so we have 2/5. Do I ever talk about money as 2/5 of a dollar? No. Okay, so what do I have to do? How do I convert this fraction back into a decimal? It's division, right? That's what this means. This means divide. So 2 divided by 5. 2 divided by 5. I'm going to write that as 2 divided by 5. Okay, how many times does 5 go into 2? None, so I'll add my 0 and my decimals and add my other 0. How many times does 5 go into 20? 4 times. 4 times 5 is 20, subtract, I get 0 remainder, so it's exactly 0.4. I still don't talk about money as 0.4, do I? No, this is equivalent to 40 cents. The Bay Bridge toll for a car was 40 cents in 1939. Man, that's dirt cheap compared to what it is now. It's probably even more expensive now. Okay, sorry. Hope you have a continued great day. Thank you. I'm sure, I have no doubt that you guys are being wonderful for your teacher. And you have the rest of class, assuming there's rest of class, to work on your homework. She may or may not have a surprise for you. We'll see. And I will see you guys tomorrow. Bye.